Alright, 8.3 is the number E.
That's not a number.
It is a number, actually. Kind of. It's actually more like the number pi. So you know that pi, not I, it's not much like I. Okay, my system base. There we go. Swivl isn't working. Okay, pi is a number that goes on forever, right? Never stops. Okay, E is the exact same thing. Okay, so it's another one. Pi we know as 3.14159 and so on, right? Okay, E is actually 2.71828, so on. Okay, so it's another number similar to pi. It's actually called Euler's number. Okay, so that's Euler's number. I know it looks weird. Okay. No, definitely not. Okay. Now, with that, it's another name for it is the natural base E, and it's actually gonna take us into logarithms here, next section. Okay. It's irrational, meaning it cannot be written as a fraction. Okay, and it was found using this. Okay. And we know, basically, so that's what E is equal to. Okay? E is equal to this, and it approaches, oops, wrong symbols, 2.71828. Okay, but it never actually, that function never actually touches the number E, but it becomes very, very close to it. Okay, so basically E is the asymptote of that function. Is what we're getting at.
In like pi where you can use 3.0 or to use any smaller number for this?
No, because on your calculators, if we look at your calculators, I told you you'd need one. So glance at that. There's a number E on it. Okay? So if you ever have to use E, don't round it, just like I would tell you not to round pi. You have to actually use the number E. Has everybody found it on their calculators? Yeah. Wait, no, it isn't. Mine's on my divide sign. No, let me see if I can find yours. No, it isn't. Yeah, I'm sure. And maybe that's what you'll have to do. See, but you should be able to hit E. Let's see here. It's here, I just not for sure exactly where. The same answer as what? What are you typing in? Like there's nothing you can't use E to the X and... Oh, I see what you guys are doing, and you're typing in 1. Okay. Yeah, that's what you'll have to do. See, my calculator has an actual, if you have a graphing calculator, it has an actual E button. So not even E to the X. I have one of those also. Okay, but you have just E. Okay, so if you have a graphing calculator, nobody in here has one, do they?
I have one now.
Okay, my sixth period class, quite a few of them have them. Okay, so yeah, you guys are going to have to use E to the X, and it's going to pop up like this, and you're going to have to type in a 1, right? Because that'd be E to the first power.
Well, it says E to X.
That's different. Oh, yeah. Oh, in your calculator when it tells you the keystrokes? Yeah. Okay. That's when you're changing exponents, though. See, like on mine, I can do my e, and then I can just raise it to a power. So it's different. So that's why I didn't know how to use your calculators, because I don't use your calculators. I use mine. Okay. But as long as we all know how to do it, that's fine. Okay. So just because it's a different number doesn't change how we do our properties and stuff like that. So if I have e to the third times e to the fourth, that's actually what? E to the seventh. Okay? That's e to the seventh. You're multiplying like bases, so you add your exponents. Okay? What if I had 10e to the third over 5e to the second? 10 over 5 is 2. 3 over 2, e to the third over e to the second is just e. What do you do here? You subtract. Okay, and then the last one they have 3e to the negative 4x squared. Okay, this one might be a little longer. That squared goes to what? Everything. So 3 squared is 9. E to the negative 4x squared is negative 8x. But since that's a negative exponent, where do I take it? To the bottom. So I actually have 9 over e to the 8x. Okay. Did any of our properties change that we've always been doing? No. Okay. Example 2 says use a calculator to evaluate. Can we all plug in that exponent? Try part B. Make sure you can plug in e to the negative 0.06. You good there?
Yes.
Okay. The book. Yeah. You can do it by hand, yeah. All right. If we're graphing, hey, how are you going to graph something? XY chart, plug it in. Okay, XY chart, plug it in. I'm not going to go through a lot of that because that shouldn't be too hard. Now, on the next page, my board's bothering me, sorry. Okay, last week we talked about compound interest, right? And we talked about how that's used in bank accounts, stuff like that. Today, they give you that same formula, okay? A equals P times 1 plus R over N to the NT. Okay, that's your compound interest. You should have that on your note card. Today, we talk about... Thanks. Yep, note card time. Continuously compounding interest. And that formula is A equals your principal times E to the RT. Okay. R stands for rate, okay, your percentage, your rate, and T is time in years. Okay, and then P is your principal or your initial amount. Okay. So, example 4, and this will actually be the last example we take a look at, says you deposit $1,000 in an account that pays 8% annual interest, compounded continuously. Okay, what is the balance after 1 year? So obviously this is my equation, right? Do I know my A? No, that's what I'm trying to solve. Do I know my principal? What did I start with? 1,000. Okay, E is just E. Okay, my rate is 0.08 times 1. And you should be able to just type that straight into your calculator. 1,000 0.08 times 1. 1,083. And the reason they say 28 is because a bank will never round up for you. Ever. Yeah. Okay, they'll save a penny here and there as much as they can. So, yes, your books are, the answer is 0.289, but on a bank account, they will never round up for you. And they always round down. Okay, they're saving pennies. Okay. Now, if you remember, we used those same numbers in the last section. Okay, so flip back to section 2. I think it was section 2. Maybe it was section 1. On page 468. Okay. 1 year compounded continuously actually ends up to be the same amount as compounded daily. Okay, that would be part C. But it's more than B and A, right? Now, as your years go on, it's going to change. It's not going to be the same as being compounded daily. Okay, because sometimes you're going to have more days in a year. You're going to have your leap years and stuff like that. Okay? How are you going to know to use that and not your compound interest equation? Yeah, it'll tell you it's compounded continuously. So use your continuously compounding interest formula. Okay? I don't have anything else out of that section. Okay, again, not a lot of new stuff really, right? Okay, we're combining a few things. Okay, tomorrow we are going to do a short quiz. Okay, so just be ready for that. It's not going to be too crazy. It will be over this stuff as well. And then on Wednesday we'll start into logarithms. We will be solving for the unknown variable. We'll be solving for x as a variable.